Greetings to all. Myself, I, J.H. Durga Mallikarjunra, working as assistant professor in the Department of Electronics and Communication Engineering in St. Martin Engineering College. Today, I am going to discuss about my topic is CMOS VLSI design. In that, we are going to discuss about implementation of logic gates using CMOS. First of all, what is CMOS logic gates? The logic gates have different types like basic gates, universal gates, and exclusive OR gates. In basic gates, we comes under AND gate, OR gate, and NOT gate. And exclusive OR gates comes under XOR gate and XNOR gate. And universal gates comes under NAND gate and NOR gate. To design a logic circuit, we are having the different characteristics like fan out, voltage levels, speed, and power consumptions. And they are having different logical families like RTL, DTL, ECL, TTL, and CMOS. In RTL and DTL are existing logical families. And coming to ECL, TTL, and CMOS, these are popular logical families. Today we are going to discuss about CMOS logical families. First of all, we are going to discuss about MOS. MOS transistors. MOS stands for metal oxide semiconductor. Okay, a technology used for field effect transistor. In that, it is the essential components in the motor electronic to test most common type of MOS transistors. MOS transistor in the MOSFET. MOSFET stands for metal oxide semiconductor field effect transistor. Metal oxide semiconductor field effect transistor, which is used in CMOS technology for digital logic circuits, amplifiers, and memory devices. Components of MOS transistors. There are three main regions in MOS transistors. They are gate, source, drain. And types of MOSFETs are N-channel MOSFETs and P-channel MOSFETs. Coming to N-channel MOSFET is also known as NMOS, and P-channel MOSFET is also known as PMOS. In N-channel MOSFET, the transistor is on when a positive voltage is applied to the gate. When a positive voltage is applied to the gate, creating a conductive path. This is the N-channel MOSFET. The N-channel MOSFET consists of gate terminal, source, and drain. The flow of current will be from upward to drain to source when you are applying the voltage at VG gate terminal, the positive terminal. The voltage will be formed as gate to source terminal. This is a conductive path. Okay. And P-channel MOSFET symbols indicates like that. What? Like the same as is N-channel MOSFET. But the main difference is for P-channel and the N-channel MOSFET is a notch or bubble. Okay. The terminals are same: gate, source, and drain. Here the current flows from gate to drain. VDS, VGD. Okay. Current flow in this direction. Okay. This is the P-channel MOSFET. Next, for P-channel MOSFET, PMOS. This is PMOS and this is NMOS. For designing of logical gates using CMOS, we are having simple logic like for PMOS, we are having the notch or bubble symbol. We can represent that using the bubble. Okay. If you are applying the voltage levels like zeros in binary values, we are having voltage levels like zeros and ones. When we are applying 0, the PMOS will be in on condition. When we are applying 1 to the NMOS will be in on condition. Okay. Next, coming to CMOS logic. What is CMOS logic? CMOS means complementary metal oxide semiconductor. It is a combination of both NMOS and PMOS. Okay, combination of both NMOS and PMOS transistors. Previously, I explained that this is a NMOS symbol, this is a PMOS symbol, and this is a NMOS symbol. Okay, PMOS consists of gate, source, and drain. The flow of current will be like this, and for NMOS, the flow of current will be like this, downward direction. The flows of current will be gate to drain. Here, the flow of current will be gate to drain. Okay. Next, what is the operations of PMOS and NMOS transistors? How the operations work? See here. In PMOS transistor, a PMOS symbol will be like this, and in PMOS, VGS is greater than less than or equals to threshold voltage, and the threshold voltage is less than or equal to VGS. The PMOS will be in open circuit, and VGS is greater than or equal to threshold voltage. The PMOS will be in closed switch. Okay, previously I explained that. Okay, coming to NMOS. In NMOS, VGS is less than or equal to threshold voltage. It will be like open switch. When in NMOS, coming to NMOS, in VGS greater than or equal to threshold voltage, it will be in closed switch. Okay. Next, CMOS pull up and pull down resistors. In PMOS, we are using mostly in CMOS. In CMOS, mostly we are using PMOS as pull up network and NMOS as pull down network. Okay. Why? Because from in NMOS, the gate to drain terminal is grounded. Okay. For that reason only we are using pull down network as NMOS. In PMOS, gate to source terminal is applied to VDD. For that reason we are applying PMOS as pull up network. Okay. This is a basic block diagram of NMOS CMOS inverter. Okay. When we are applying for PMOS, both combination of PMOS and NMOS is known as CMOS inverter. Both the gate terminals are combined and formed as input terminal, and both the drain terminals are combined and formed as the output terminal. This is a V out. Okay. This is a working of CMOS inverter. When we are applying input, to the CMOS inverter, one has a logic 0, the output will be as 0. CMOS means nothing but an inverter. When we are applying okay, when we are applying logical 0, as input, the output will be displayed as 1. Means when we are applying 0, previously I explained that when we are applying 0 to the PMOS means in PMOS we are having the notch, okay, notch symbol. For that reason we are simply identifying that PMOS 0 means it is in closed switch. From that, when we are applying 0, it will be like closed switch, and VDD is supplied to supplied from PMOS, and it will be displayed as V out as the output. And 0 means it will be in NMOS will be in off condition, like it will be in open switch, and the ground not be, and ground is disconnected. It will open switch from VDD to power supply is out displayed as output. It will be like minute threshold voltage. Okay. When we are applying 0 as input, okay, 1 as input, 5 volts. PMOS is off condition. 1 means 5 volts. In logical digital values, we are applying 5 volts as binary value. Okay, 0 as 1 volt in logical value. V in means we are applying 5 volts here. 5 volts we are applying means in PMOS it will be in off condition, and NMOS it will be in on condition. Okay, like this. Output will be 0. By using this CMOS inverter technology, we can design a CMOS NAND gate and NOR gate. Okay, how we are going to design? We are look into this. First, we are going to design NAND gate. Basic gates are logic gates. In logic gates, there are three types: basic gates, AND gate, OR gate, and NOT gate. And universal gates. By using universal gates, we can design basic gates like AND gate, OR gate, and NOT gate. Okay. Universal gates are two types: NAND gate and NOR gate. And exclusive OR gate or XOR gates and XNOR gate. Exclusive gates. These are the basic gates, logic gates. Okay. Now we are using CMOS technology. By one, we can design first NAND gate and NOR gate. Or first we are implementing NAND gate using CMOS VLSI. Okay. First to design the CMOS VLSI NAND gate, what is the first we need is truth table. For NAND gate, we are having two inputs and one output 1. Okay. First one, A, B are the input and Y is the output. Okay. The basic combinations are 0 0, 0 1, 1 0 and 1 1. The output expression will be like AB whole bar. Okay. 0 0 0 0 1 0 0 0 means 0, 0 1 means 0, means complement now 1, 1 0 means 0, complement 1, 1 1 means 1. Okay. 1 1 means 0, complement 1. Okay. Triple 1 0. This is the output expression. Now we are going to design NAND gate using CMOS. NAND gate. To design logic gates, we need to know for PMOS, if the products are in the PMOS, product terms are in PMOS. Product terms are in PMOS. The PMOS will be like, PMOS will be in parallel. And for NMOS, if the product terms, if the sum terms are in NMOS. Okay. By using that, we are going to design NAND gate. To design NAND gate, we are having two inputs for PMOS This is a PMOS, one input A, and PMOS, another input B. Okay, both are combined together and formed. This is NMOS. NMOS are in series. This one A, this one B. The output will be here, V out, and both are combined. This is called VDD, and here ground. Okay, this is a NAND gate using CMOS logic diagram. Okay, check whether the output is verifying or not. When we are applying inputs 0 0, A is 0, A is 0, B is 0. Here also A is 0, B is 0. Here I told that for N, this is PMOS. Okay, and this is NMOS, PMOS. In PMOS, VDD means nothing but plus 5 volts. Okay, ground means nothing but 0 volts. Okay, when we are applying 0 for PMOS means it will be in on condition. On condition means the switch will be closed, the loop will be closed, and here this is also 0 means the loop will be closed. Okay, the power supply will be like this. Output, the output will be like 1. When we are applying 0 0, the output will be like 1. Output will be 1. Okay, and the NMOS will be in off condition. Off condition means it is a open switch. There is no power supply here. Okay, that's why this will be in off condition. And coming to 0 and 1 condition, in 0 A will be 0, B will be 1. Okay, here we are applying 0 for A. Okay, here we are applying 0 for A, 1 for B. 0 for A and 1 for B. 0 means in PMOS it will be like closed switch. A power supply will be like this, and for PMOS it is in the parallel connection. It will be 1 means it will be like off condition, open switch. Okay, there is no power supply to that. And for NMOS it will be like 0. 0 means it will be like in off condition, means closed switch. In NMOS, in 1 means it will be like closed switch. Here open switch, here closed switch. But from here to ground to, there will, for the output there is no connection, and that way only the output will be 1 here. Only one power supply. A is only supplying to output. That's why only the 0 comma 1 we are applying means the output is 1. Okay, next 1 0 condition, and we are applying 1 here for A and B for 0. Okay, A for 1 and B is 0. Now you can check the conditions. When you are applying for 1 for PMOS means it will be like open switch. Okay, there is no power supply, no connections, and for PMOS it will be like closed switch. Okay, here NMOS it will be like 1 means it will be like open switch. Closed switch, it will be like closed switch. Here it will be like in open switch. There is no power supply to ground. Okay, directly the power supply is from here to output. Okay, like the output will be 1. Okay, now 1 1 condition. When you are applying 1 to 1 1, A to 1, B to 1. Okay, when you are applying A for PMOS, it will be like in off, means closed switch, open switch. Both are in open switch. These are all open switch. There is no power supply from ground VDD to output, and when we are applying ground, means it will be like closed switch. Both are in closed switch. The power supply will be flow from ground to V out. Here the condition will be 0. Now the condition is satisfied. Okay, this is NAND gate using CMOS. Okay, and other condition, NOR gate. NOR gate means it is nothing but y equals to a plus b whole bar. It is nothing but addition operation. Okay, a, b, and y. 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 means 0. Complement no 1. 0 means 1, 0. 1, 0 means 1, 1, 0, 0. Okay. Okay. This is a NOR gate operation. Here we are taking ground. Here VDD, power supply, symbol. Okay. The flow of current will be like this, and the flow of current will be like this. Here B, here A. This is the output connection. Okay, VDD is nothing but plus 5 volts. Here 0 volts. Okay, this is one A, this one B. Now checking one by one condition. If you are applying 0, 0 means if you are applying 0, comma 0 means 0, comma 0. 0 means it will be like in open switch, like a power supply will be like this way, means the output will be 1. It is satisfied. Okay. Next 0, comma 1. When you are applying 0 and here 1, now output will be like this is the 0, here 1. Output will be like this flow. Okay, that's why the output condition will be 0. It is also satisfied. And next condition 1, comma 0. A is 1, B is 0. Here A 1 means it will be like open switch. There is no power supply. Okay, and next in condition in NMOS like 1 and 0. 0, 1 means it will be like closed switch. The power supply will be 0. This is also satisfied. Next 1, 1 condition. In 1, 1 condition 1, 1. Okay, in 1, 1 condition, in 1, 1 condition it will be like open switches on, and the output power supply will be here. Okay, V equals to 1. This output will be satisfied. Okay. Next, coming to the CMOS logic design, we are discussed about NAND gate and NOR gate. Next, AND gate and OR gate. Okay. Let us see some small animated video how we are designing, how we are using CMOS as an inverter. Okay. See, this is a complementary metal oxide semiconductor. We are using CMOS for NMOS, PMOS and the NMOS are the substrate in CMOS. PMOS is a P-channel MOSFET, N substrate is the N-channel MOSFET. In P substrate we are having polarities are P plus and the substrates are N plus and N plus ions. And N substrate we are having the P plus is the polarities of P plus ions, and N plus is the N plus ions. By using this, we can design the CMOS NAND gate. First, by using this, see, here we are using, first we are discussing about CMOS complementary NAND gate. In the CMOS NAND gate, we are using pull up as a NMOS, PMOS, and pull down as a NMOS. In pull up, the PMOS will be consist of source and the drain terminal and gate. In that in the PMOS, we are having the notch, we are discussing about notch, okay, and pull down, we are not having a notch, okay. By using this CMOS inverter VLSI, we can design NAND gate, NOR gate, XOR gate, XNOR gate, and basic gates like AND, OR, and NOT gate. NOT gate is nothing but CMOS complementary, also known as NOT gate. Okay, CMOS inverter. Now we are going to discuss about NAND gate. AND gate, by using AND gate, okay, AND gate, basic gates in that AND gate. AND gate is nothing but NAND plus one inverter. NOT gate is nothing but AND gate. Okay, previously we discussed about NAND gate. NAND gate, what is NAND gate? The symbol will be like this. PMOS A, B are the inputs. These are in series condition. NMOS will be in series condition. NMOS. This is a PMOS. PMOS. Here we are supplying the VDD. VDD is nothing but plus 5 volts. Ground, nothing but 0 volts. B, A, P. Here we are taking as a output. But I told that AND gate is nothing but NAND plus NOT. Okay. Here the output is taken and forwarded to inverter. Inverter is nothing but NMOS plus PMOS. Okay. This is PMOS. This is NMOS. Here we are taking as the output. Okay. VDD and here ground. This is the output for AND gate. Now applying input. Okay. To know the AND gate operation, first we know the AND gate truth table. Okay. AND gate truth table consists of 2 inputs and 1 output. Okay. The combinations are 0 0, 0 1, 1 0, and 1 1. Okay. The output will be like 0 0 0 and 1. Okay. This is the AND gate output. And coming to next OR gate. OR gate. OR gate is nothing but NOR gate plus NOT gate. NOT gate. OR gate truth table is 2 inputs and 1 output. Y equals to A plus B. Okay. And tomorrow, next class we are discussing about exclusive OR gates. Thank you.